Everyone, welcome. This is Geometry, Module 5, Topic 1, Lesson 1. Specifically, we're on page 777. Please have your book. Please have some highlighters. Please have something to write with, pencil, pens, etc. In fact, I'm going to be using 4 highlighters because there were 4 different choices that needed to be made in the tree diagram when we're watching Amalia or Romeo or ourselves go to the pizzeria and order from the different choices for toppings, crust, thickness, like size, etc. And so from that, in the last video, we talked about making a tree diagram, but where's the probability in that? Where's the probability in the tree diagram? Because this is what this is all about. Computing probabilities and looking at the sample space, the number of outcomes, the event, etc. Those wonderful vocabulary words. What does each outcome of the sample space represent? Well, let's just be clear here. This is a specific path to an outcome for Romeo, where Romeo ordered a large, round, thick pepperoni pizza. And there were 16 total choices that Romeo could have arrived at in making 4 separate decisions. Each outcome of the sample space represents a specific type of decision that was made to achieve a one-topping pizza. Each outcome is the result of 4 specific decisions. Compare the tree diagram that are created by Amalia and Romeo, which we did a little bit. Go back and watch the previous video, but the thing that was emphasized in that video was just the order in which they made their selection. However, you could find Amalia's path from round, thin, small pepperoni in Romeo's tree diagram. So let's bring in some color. She chose a round and thin and small pepperoni. So Amalia could also have used Romeo's tree diagram to produce the same scenario. And likewise, Romeo, the way that he structured his tree diagrams, could also be found and got to his outcome, could also be sketched out in this one as well. He chose a large, round, thick pepperoni. And so Romeo, his decision-making tree process can also be found in Amalia's tree diagram. They're different paths, but they still produce what they each wanted, a pizza with specifically a certain set of decisions made to make that pizza. So if we compare the tree diagrams created by both of them, well, they're similar because they contain the same number of choices. But they're different because they don't contain them in the same order. Different because their orders of choices are not the same. They're like switched around. Their order of choices are switched. Does the arrangement of the tree diagram then affect the total number of possible outcomes? I mean, no. Like I tried to emphasize with the 2 highlight colors, these paths. So pink and blue being Amalia's and Romeo's, choices for a certain type of pizza. The fact that they both have in total 16 outcomes by adding up 16 outcomes here. If you follow a branching path from start to finish and you talk about what was decided in making that, they both produce 16 outcomes. So does the arrangement of the tree diagram affect the total number of possible outcomes? No. It doesn't. Explain why or why not. There are still 16 total outcomes. And you can find the order type that Amalia's tree diagram makes, and it's different from Romeo's. You can find equivalent branching paths through them. you know, instead of a tree diagram, let's actually like maybe create an organized list. And I've gone ahead and created the first like 18% or 80% of it. So with a key that lets us know small, L, large, SQ for square, R for round, P for pepperoni, M for mushroom, capital T for thick, little t for thin. We can list all possible outcomes from this pizza design right here. In fact, am I following? I think I'm following Romeo's arrangement of the tree diagram just because, I don't know, it is the arrangement I followed. No specific deal to it. It could be shifted around, mind you. So for a small pizza, this would represent a small square pepperoni pizza with thick crust. It's not actually others. So switch in the pepperoni and mushroom around with the thick and the thin. Small square pepperoni with thin crust. And so for that reason, that is for the small square pepperoni pizza options, the two different types that are available, thin crust, thick crust. If you list them all out meticulously, there are 8 different pizza choices for a small pizza. And there must therefore also be 8 different pizza choices for a large pizza. What's missing is, let's see, large square pepperoni thick, large square pepperoni thin, large square mushroom thick, large square mushroom thin, large round pepperoni thick, large round pepperoni thin, large round mushroom thick, and large round mushroom thin. That's an organized list of all of the arrangements. A little more difficult to see than a tree diagram, but certainly complete and contained. All of them are there. How many possible thick and round pizza specials can you order? I'm looking at question 5 right now, and maybe it's worth a highlight. So I'm going to look for thick and, meaning together they have to both be conditions of the pizza. The word and is the key word here. And so I'm going to use orange for this one. I'm going to go back into this ordered list and highlight them. I need thick as an option. I need round as an option. I need them both together. There's one. It's a small, round pepperoni thick pizza. And there's one. A small, round mushroom and thick pizza. But round and thick being the two criteria that question 5 wants us to know about. Same thing with a large. Large, round pepperoni pizza and large, round mushroom pepperoni pizza. That means that there are, I should write this in probability notation. So probability of thick and round pizzas, there are 4 out of 16 total pizzas. How many different possible pizza choices are square but do not have mushrooms? So bring in pink for this one. We want square but do not have mushrooms. So highlighting square, pepperoni, square, pepperoni, square, that one's mushroom. Okay, square pepperoni. We just want not mushroom, right? We want them to be together. We want a square pizza with no mushrooms. And that happens, once again, 4 times. Let me use the notation that we picked up from page 775. What's the probability of getting a square pizza and mushroom complement, right? Because the little C represents the other option. So the other option from mushroom is pepperoni. Oh, I could write it this way. Square and pepperoni, right? That's what it has to be. If it's not a mushroom pizza, it's a pepperoni pizza. And for us, that happens to be 4 that I highlighted pink out of 16 total. Same probability as number 5, just a different scenario, a different event that we're trying to generate. You guys, thank you for watching page 777 notes, 777 notes. We have finished activity 1. Up next is activity 2. And in that activity, we will talk about the sample space and what we can do with sample space for a different scenario. Same idea. We're going to write all possible outcomes, maybe use a tree diagram to do it. We're going to talk about some probabilities of a certain scenario happening, and ultimately further our conversation on what probability means and how we can use it to make decisions and know if our decisions are the right choices for a certain outcome that we want to get. Thanks for watching this video, watching this episode, and I will see you on page 778 in the next one. Have a good one.